All right, in this video, we're going to talk about partial fractions. And just as a quick note, this video is not going to be a full step-by-step in performing the whole partial fraction decomposition. This is more of an intro into partial fractions, what they're comprised of, and just some of the basic terminology used in partial fractions. For a more step-by-step approach into actually working with the decomposition of partial fractions, please check out video 2 and any subsequent videos in this series. All right, so what I want to do is I want to do a little lead-in into what partial fractions are, and I want to back up just a little bit. So normally when we're working with rational expressions, so I'm just going to write one here. We're going to have 3 over x minus 4 minus 2 over x plus 2. And normally when we're working with rational expressions, we're usually combining them. We're either adding or subtracting, multiplying or dividing them. And I'm going to do that right here. So if we were going to combine these two fractions, subtract them, we need a common denominator. So my common denominator here would be the highest power of every different factor. So I have one factor right here. I have another factor right here, and the highest power of each factor would be 1. So that's going to be my denominator. We're going to just take both of these factors, and I'm just going to drop it under my fraction bar here. And then what we're going to do to combine this or subtract these, we would multiply both fractions by the terms in your common denominator. So I'm just going to do it on both sides, just so I have that visual. So to combine our fractions, we're going to take this, these expressions here, these binomials, and I'm going to distribute that into my brackets. So if we do it to the first fraction here, we're going to wind up doing this times 3 over x minus 4. And what's going to happen is the x minus 4s will cancel, and I'm going to be left with 3 times x plus 2. And then we're going to do it to the second fraction, and then what's going to happen after I multiply these, the x plus 2s will cancel, and we're going to be left with negative 2, so we have to carry that negative, times x minus 4. All right, and then what we're going to do is just simplify the numerator and the denominator. We're going to multiply it all out. So we're going to distribute the 3 and then the negative 2. And in the bottom, we're going to multiply all those terms out. So we're going to be left with, in the numerator, we're going to have 3x plus 6 minus 2x plus 8. And when we multiply all that in the denominator, we're going to wind up with x squared plus 2x minus 4x minus 8. All right, and then we're just going to combine everything. In the numerator, what we can do is we can combine the 3x and the negative 2x. So this is going to leave us with x, and we can combine the 6 and the 8. So that'll leave us with 14. Right? And then in the bottom, in the denominator, we can combine the two middle terms. So that's going to leave us with x squared minus 2x minus 8. And that's all pretty much standard fare for working with rational expressions. So what we're going to do in this section, though, we're actually going to go backwards. And what partial fractions are, what the process of creating partial fractions actually is, we're going to actually take our answer, what we ended up with, and we're actually going to put it back to where it came from. It's kind of reverse engineering this fraction to where it came from. We're going to put it back into the sum of its parts, which was, originally, it was 3 over x minus 4 minus 2 over x plus 2. Okay? So we're going to take a rational expression, and we're going to reverse engineer it, decompose it, and then break it up into the sum of its parts. And that's basically what partial fraction decomposition is all about. Now, before we can do that, again, this is just an intro video into this. It's kind of like a prerequisite video. I'm just going to cover some terms before we can get into the process. And then, my other videos, video 2, 3, and so on, I'll cover all the steps. So the terms used to do the partial fractions and how I like to think of it. Let's have a function here. We'll have q of x equals, and we're going to have it already factored, so it's going to be x plus 1 times x squared minus 3. All right, so I have these two factors. Now what you're going to do is you're going to look inside the parentheses first, and that's kind of how I do it. All right, that's my methodology. I always look inside the parentheses, and I want to see what exponent is on my variable. And on this one, it's a 1, and on this one, it's a 2. Okay, that's important because that's going to tell us what type of factors we're dealing with. If on the inside of your parentheses, your term is, or your exponent is a 1, this is going to be considered a linear factor. Okay? And then you look on the outside of the parentheses, and I can see I don't have any exponents, so we know my exponent there is a 1. So if your exponent is a 1, this is considered a single factor or a non-repeated factor. Okay? Again, it's linear because the exponent inside here is 1, and it's going to be considered a non-repeated or a single factor because the exponent on the outside is a 1. All right, now we're going to go to the second one, and I'm going to look inside the parentheses, and I see my exponent is a 2. Well, we know if my highest exponent is a 2, that's going to be a quadratic factor. And I also see that my exponent on the outside is a 1. So again, this is going to be a single or a non-repeated. So this is a single quadratic factor, right? Or non-repeated. You know, we can use those terms interchangeably. All right. So what's inside is going to tell us whether it's linear, quadratic, cubic, and on the outside it's going to tell us whether it's repeated or non-repeated. Now, I'm going to extend this a little bit in the next example. So let's use another function here. So let's use p of x, and let's do this one. So if we had x plus 1 squared times x squared plus 4 squared times x plus 5. All right? So again, I'm going to look inside my parentheses here for these three factors. We're going to look at this first one. I see that the exponent inside is 1, so this is going to be considered linear. But the exponent on the outside of the parentheses is more than 1. If it's more than 1, this is going to be considered a repeated factor. And you have to deal with the repeated factors a little differently. That's why we're kind of making this delineation here. We're kind of, separating these into categories. And that's how these problems are going to go. They're going to be separated into categories, and that's how I'm going to do the videos. All right? So if the exponent on the outside is bigger than 1, it's going to be considered a repeated factor. Now, if I look at the second factor here, this one is actually going to be, it's a quadratic factor because inside the parentheses was a 2. So again, just like the one I had above it, this was a quadratic factor. But because this is also a 2, this is going to be repeated. And again, that does make a difference in how you separate or create your partial fractions. All right, and then the last one, it's basically what we had above. So I have an exponent of 1 here and an exponent of 1. So that's just going to be, so my third factor here, we're just going to have our standard. We have a linear, and the exponent is a 1. So this is just going to be a single linear factor, non-repeated. Okay, so that's how you do that's what how the terms are going to break down. Now let me show you how we create the fractions just very quickly, and then in the next video, like I said, we're going to take through all the steps. All right, so let's create a function here. Let's have r of x equals, I have 9x squared minus 9x plus 6 over 2x minus 1 times x plus 2 times x minus 2. All All right, so the first thing you're going to do when you do these, you're going to see me do this in the next video. The first thing you want to do is you want to factor your denominator as completely as possible. All right, you don't really care about the numerator in this case because we're creating the numerator. Your denominator is where it, it's kind of where it's at. That's where you want to make sure everything is factored completely. All right, so you're going to factor your denominator, and then this is kind of where you begin your decomposition. You're going to decompose your fractions. Okay, it sounds kind of morbid, but that's the terminology used. You're going to decompose your fractions. So here's how you do it. You're going to look at your factors in your denominator. Let me come back to my highlighter here. All right, and in my denominator here, I've got, if we go back to the terms I used above, what I have, I'm just going to write it over here. I'm going to write my factors here. If I look at this one, again, the exponent is 1 here, and it's 1 here. So I have a linear factor, and it's single for that first factor. And then we're going to look at the second factor. So that's also a linear factor. So the second factor is also linear. And again, that's not repeated because the exponent there is 1. So that's a single. And then the third factor is going to be the same. So we're going to have a 1 here and a 1 here. So that all three factors are going to be single linear factors. All right? So that's actually a good thing because that is kind of like the easier way, it's the easier type of a problem to deal with. When everything is just single linear factors, it makes life a lot easier. So what you do is you're going to wind up, if you see I have 3 different factors in my denominator, right? I have these 3 factors. What you're going to do is when we do this decomposition, you're going to create 3 fractions here. So we're going to have 1 is going to be created for this first factor. So it's going to be, you're going to put 2x minus 1 in the bottom. And you're always going to put plus signs in between your fractions. So we're going to create another fraction for this factor. Again, I'm going to go through all this in detail again when we do one of the problems for real. And then we're going to create another fraction for the last factor. All right? So you are going to have a fraction for every different factor in your denominator that we started with, okay? When you have single linear factors, you're going to have a fraction set up for every different factor in your denominator. Now, I'm going to change that. Like I said, this is going to change a little bit when the factors become repeated. So when you have repeated factors, I'm going to change the rules a little bit on that. So I'm going to deal with that in the 3rd video on this series. So just for now, when you have single linear factors, you're going to create a separate fraction for each separate factor. I have one for the 3rd one here. All right? And again, if the factors are repeated, then it changes a little bit, and I'll get into that in the 3rd video. So then that's good. So that's basically what you're doing. Again, I have 3 factors, 3 different linear factors. I have 3 different fractions, okay? Now we have to figure out the numerator. So the numerator, the terms in the numerator are actually going to represent what I have in the numerator here. Remember, what we're doing is we're taking a rational expression and we're kind of breaking it up into the sum of its parts. Well, we need some terms in the numerator that either add or subtract up to 9x squared minus 9x plus 6. And the way you start it off is you have to put placeholders for those terms. So what you do is your numerator is going to start 1 degree less than the denominator. Okay? So for instance, in our examples, all our denominators were linear. So 1 degree less than linear would be constant. So your numerator is going to start 1 degree less than the denominator, and it's going to go all the way, it has to account all the way down to the constant term. Okay? And again, this is going to be more in detail in the third video and any subsequent videos. So for now, what we have is just linear factors. I just have linear factors in the denominator. So again, we have to start 1 degree less than linear. So 1 degree less than linear is constant. And we have to put a placeholder in here. And the placeholders are going to be variables. All right, and we're going to start the variables off with A. So your first fraction is going to be A. And you're going to, like I said, you're going to account for these all the way down to the constant. Well, I start with a constant, so I'm pretty much ending with a constant. So I don't have to do anything else with this fraction. And you're going to go to the next fraction. You're going to continue with the alphabet, so you're going to go to B. You do not repeat your letters in any of your fractions. And then the next fraction also has a linear factor, so we're going to go to C. And then, so on and so forth. So you always start your numerator 1 degree less than your denominator, and you're going to account for all of your factors all the way down to the constant, all of your terms all the way down to the constant term. So when we have quadratic factors in the denominator, all right, we're going to have to account for the linear and the constant, all right? And if we had a cubic factor, what we would have to do is, in the numerator, we would have to account for the quadratic factor, the linear factor, and the constant factor, all in that numerator, all right? And then so on and so forth. And that's how the numerator works, all right? You start with, your first fraction is going to start with A, and you just go down the alphabet. Do not repeat any letters. And, depending on whether or not you have a quadratic factor or whether the factor is repeated, is going to change how these fractions are created, the dynamics of these fractions. So again, we're going to get into all that in the next series of videos. Stay tuned for the next bunch of videos, and we will just work through all the steps together, and I will catch you in the next one. Okay? Take care.